What if tonight the moon simply vanished? No explosion, no warning, no dramatic crack across the sky. You step outside, look up, and the space where the moon has existed for 4.5 billion years is just empty. At first, you might shrug. It's just darker. That assumption would be your first mistake. Let's interrupt the Hollywood version right now. Earth would not spiral out of orbit. We would not drift into deep space. The moon does not control Earth's path around the sun. The sun's gravity does that. Over 99% of the gravitational influence in our orbit comes from it. So no instant apocalypse. But what happens next is slower, deeper, and in some ways more unsettling. Within hours, coastlines around the world would notice something strange. The tides would shrink. Right now, the moon is responsible for about 2/3 of Earth's tidal force. The sun contributes the remaining third. Remove the moon, and tides would immediately drop to roughly 1/3 of their current strength. That might sound minor. It isn't. Tides are not just waves lapping at the beach. They're global energy systems. They move billions of tons of water daily. They circulate heat. They transport nutrients from deep waters to coastal ecosystems. Entire marine food chains depend on tidal rhythms. Crabs time their reproduction to the tides. Coral spawning is synchronized with lunar cycles. Many fish species rely on tidal flows for migration and feeding. Reduce tidal strength dramatically, and you disrupt ecosystems that feed hundreds of millions of people. Global fisheries, already under pressure, would face massive ecological instability. And that's just week one. Now here's where things get more serious. Earth is tilted at about 23.5 degrees. That tilt gives us seasons. Summer, winter, spring, fall. The moon acts like a stabilizer for that tilt. Its gravitational pull helps prevent Earth's axis from wobbling too wildly over long time scales. Without the moon, Earth wouldn't tip over tomorrow. But over tens of thousands to millions of years, our axial tilt could vary far more dramatically than it does today. Computer simulations suggest Earth's tilt could potentially swing between near 0 degrees and over 40 degrees. Let that sink in. If Earth tilted closer to 0 degrees, seasons would nearly disappear. The equator would stay hot. The poles would stay cold. Ice caps could expand. But if Earth tilted toward 40 or 45 degrees, seasonal extremes would intensify dramatically. High latitudes could experience scorching summers with 24-hour sunlight and brutally long winters of near-total darkness. Climate zones would shift. Agriculture belts would migrate. Ecosystems would struggle to adapt. Civilization wouldn't collapse overnight. But long-term climate stability, the quiet, invisible benefit we get from the moon, would be gone. Now here's something that sounds small, but isn't. Days would change. The moon is gradually slowing Earth's rotation through tidal friction. As ocean tides move, they create drag. That drag transfers energy to the moon, pushing it about 3.8 centimeters farther away from Earth every year. We know this precisely because astronauts left laser reflectors on the moon during the Apollo missions, and scientists still bounce lasers off them to measure the distance. Right now, Earth's rotation slows by about 1.7 milliseconds per century. Without the moon, that braking effect would weaken significantly. Over millions of years, Earth would spin slightly faster than it otherwise would. Days would be shorter compared to our current long-term trajectory, and planetary rotation affects more than your clock. It influences wind circulation, storm systems, and ocean currents. Even small changes over geological time reshape climate patterns. But let's bring this back to something personal. Night. A full moon can illuminate Earth's surface at about 0.1 to 0.3 lux. That's bright enough for humans to walk outdoors without artificial light. For most of human history, moonlight shaped behavior, travel, hunting, farming, rituals. Without the moon, Nights would be significantly darker except for starlight. No more bright lunar disk rising over the horizon. No more eclipses. No more predictable lunar phases guiding calendars. Many ancient civilizations built their entire time-keeping systems around the moon. And it's not just culture. Many nocturnal animals depend on lunar light. Predators use it to hunt. Prey use it to hide. Sea turtles hatch on beaches and navigate toward the brighter horizon. Historically, the moonlit ocean. Coral reefs synchronize spawning events with specific lunar phases. Remove the moon, and you remove biological rhythms embedded through hundreds of millions of years of evolution. Now, let's address a common fear. Would earthquakes and volcanoes suddenly increase? The moon does create solid earth tides, subtle flexing of Earth's crust. Scientific studies show these forces can slightly influence the timing of small seismic events, but they do not cause major earthquakes or volcanic eruptions. So no, the planet would not crack apart. But here's a deeper question. How do we get so lucky to have a moon this large? The leading explanation is the giant impact hypothesis. Around 4.5 billion years ago, a Mars-sized body collided with early Earth. Debris from that impact eventually formed the moon. That same event likely influenced Earth's tilt and may have contributed to stabilizing our climate long enough for complex life to evolve. And here's the controversial angle. Earth's moon is unusually large compared to its planet. In our solar system, most moons are tiny compared to their planets. Some scientists suggest that having a large, stabilizing moon might increase the chances of long-term climate stability. When astronomers search for habitable exoplanets, they consider many factors: distance from the star, atmospheric composition, water. But a large moon could also matter. We might be underestimating how rare this setup is. Now imagine the psychological shock. For all of recorded history, every human who has ever lived has shared the same moon. It inspired mythologies, religions, poetry, navigation techniques, and the first human footsteps beyond Earth. Between 1969 and 1972, 12 astronauts walked on its surface. If it vanished, global panic would be immediate. Telescopes would scan the sky. Space agencies would scramble for explanations. Social media would explode with theories. Religious interpretations would surface. Markets might even react, not because of physical destruction, but because something constant and ancient suddenly disappeared. And here's the final twist. The moon is already leaving us. It drifts away at 3.8 centimeters per year. Billions of years from now, if the expanding sun doesn't engulf Earth first, the Earth and moon would eventually become tidally locked, showing the same faces to each other permanently. The moon feels eternal. It isn't. It's just stable on human timescales. Without it, Earth would still orbit the sun, oceans would still exist. Life would likely survive, but the planet would be less stable, more climatically unpredictable, biologically disrupted, darker at night, slightly faster spinning, and over immense timescales, possibly far more extreme. The moon is not decoration. It is a gravitational partner quietly shaping our tides, our climate stability, our biological rhythms, and even the length of our days. So next time you see it hanging in the sky, realize you're looking at one of the main reasons Earth has remained stable enough for complex life to thrive for hundreds of millions of years. If this changed how you see the moon, follow for more deep dives that challenge what you think you know about our universe. And now I want to hear from you. If Earth never had a moon to stabilize it, do you think intelligent life would still have evolved here, or are we the product of an incredibly rare cosmic accident?